In this video, we're going to talk about the row space and column space of a matrix, as well as how to find a basis for a row space. Given an m by n matrix A, the row space of A is the subspace of Rn spanned by the row vectors of A. The column space of A is the subspace of Rm spanned by the column vectors of A. In order to find a basis for a row space, if a matrix A is row equivalent to matrix B in row echelon form, then the non-zero row vectors of B will form a basis for the row space of A. Let's consider the following 3 by 4 matrix. We can find the basis of the row space by converting this matrix into row echelon form. We can do this using either row operations or technology. I chose to find it using a TI-84 graphing calculator, and I achieved the following result. So this is the result I obtained using the reduced row echelon feature on my TI-84. Therefore, the basis of my row space is 1, 2, negative 2, 0, and 0, 0, 0, 1. It's also possible to find the column space of a matrix, and we do this a little differently. Let's take a look at the matrix we started out with in the last problem. To find the column space, we'll first take the transpose of our matrix. In other words, we'll rewrite our rows as columns and our columns as rows. Then, we proceed as we did for finding the basis of a row space. We'll take the reduced row echelon form of our transpose matrix. Note that if you're using a graphing calculator, you may get an error if you try to take the reduced row echelon form of your transpose matrix. One way to work around this is to set up your matrix as a 4 by 4, with your fourth column being a row of zeros. taking the reduced row echelon form here. Yields the following matrix. And this result gives us the basis for our column space. So the basis for the column space in column 1, we have 1, 0, 19/7, and 0. And column 2, 0, 1, 8/7, and 0. Recall that the row of zeros in the fourth column was just a dummy row, so we're able to erase the last 0 in each column. And our final result here gives us the basis for the column space of our matrix. This concludes our example. I hope you found it helpful, and we'll see you next time.